Hello, in this video, I'm going to show you an example about alpha-beta pruning. I will use our homework assignment, which is the domino game, as an example. So if we call get best move on vertical pair with a limit of 2, your program should be able to return this result, which means the best move is 0, 1, which is this, and the best value is 3. And finally, your program should be visit 10 nodes, 10 leaf nodes in total. So before we begin, I just want you to know that whenever we found alpha is bigger or equal than beta, we will prove the node, which means we do not take a look at the nodes after that leaf node. So in the beginning, we initialize our alpha and beta to negative and positive infinite. And we generate these successors and we pass alpha and beta value to the mean node. And finally, we reach our leaf node and we start to modify the values. Now, the first thing you need to know is that we only modify beta in mean nodes. So here, the board value is -1. We found a better beta value, so we update it to -1. Similarly, we found another board with -3, so beta is updated. The other two nodes here does not have any influence on the beta value, so we in total visit 4 leaf nodes for this move, and the beta is set to be -3. And then we pass this value along the route. So we modify alpha to -3. That is the value for current max node. So again, we pass alpha and beta to the mean nodes, and we then find these 2 leaf nodes, and we pass the value 3 to beta. And now we find a better value, so we modify beta to 3. The second board has the same value, so we do not update beta. Now we have visited 6 leaf nodes. We then pass this value to the root, and we found that it's a better value, so we update alpha to 3. Again, we pass alpha and beta to the third mean nodes. And the first thing we find that this board has a value of -1, so we update beta. And now we immediately find that alpha is bigger than beta, so we prune it, which means there's no need to take a look at the leaf nodes after that. And now we have visited 7 nodes, and we pass the value of -1 to the root. And there's no need to update alpha for this one. Again, we pass alpha and beta to the fourth node. We update the value of 1 to beta, and there is, again, a pruning condition. We found alpha is bigger than beta, so we prune it. We pass value 1 to the root, and now we have visited 8 nodes. So we repeat this process. Alpha and beta is passed here, and visit the node with value of 3. We update beta. We found we can prune it. So we do this again. Finally, one last round. We pass 3 to the root, and we pass alpha and beta here. We found the value of this board is 0. We update beta. Alpha is bigger than beta, so we prune it. So that ends our searching process. We have visited 10 nodes in total. The best value associated with the value of alpha, that is 3, which means this move, we can guarantee that we can have a value of 3. And if you take a look at this node, suppose we choose to play this, and the main player is playing optimal. So he will definitely choose this value. So which means beta is -3. That is our worst choice. And you may also want to ask, what if we choose this one? This board also has value of 3, but why don't we choose it? This is because our program is searching in a certain order. So you all read this nested for loop, so we search from here to here to here to generate our successors. And if you follow this order, your program will definitely return this result. And that is another warning that the result of alpha-beta pruning is depend on the result of your searching process. So order matters. And thank you for watching.